Alright folks, welcome to another advent of code. Let me make sure. Oh no. Well, that's probably why I'm not coming through. Is that the camera's on the floor. Oh, would you look at that. So much better. We're gonna test. Oh yeah, we're good to go. Okay. And it's 9 p.m. Let's read problem 18. Boiling boulders. You and the elephants finally reach fresh air. You have emerged near the base of a large volcano that seems to be actively erupting. Fortunately, the lava seems to be flowing away from you and towards the ocean. Bits of lava are still being ejected towards you, so you're sheltering in the cavern. Exit a little longer. Outside the cave, you can see the lava landing in a pond and hear it loudly hissing as it solidifies. Depending on the specific compounds in the lava and the speed at which it cools, it might be forming obsidian. The cooling rate should be based on the surface area of the lava droplets, so you take a quick scan of the droplet as it flies past you, your puzzle input. Because of how quickly the lava is moving, the scan isn't very good. Its resolution is quite low, and as a result, it approximates the shape of the lava droplet with a 1x1x1 cubes on a 3D grid, each given as XYZ. Oh, we've got a three-dimensional problem. To approximate the surface area, count the number of sides of each cube that are not immediately connected to another cube. So if your scan were to give you only two adjacent cubes like 1 on 1, 2 on 1, each cube would have a single side covered and 5 spaces exposed, the total surface area of 10 sides. Here's a larger example. In the above example, after counting up all the sides that aren't connected to another cube, the total surface area is 64. What is the surface area of your scanned lava droplet? Get your puzzle input. Much longer. Okay. So, and what are the sides of these? These all appear to be 2 digits. Like I'm not seeing a 100 or anything. Yeah. Nothing. Okay, cool. So let's go here, project, level 18, and we want level 18 data.txt, and we can mess with the rest later. File, level 18 data.txt. Please do add it to GitHub. Fantastic. So for this, while scanner.dat has next line, if we look at the input, oh, and while I'm thinking about it, let me move my face to this side, because I think more often than not I end up putting the code on the right side and then you can't see what's going on. Okay, we want to make this level 18 for both of these so that we don't end up going like what's going wrong. While scanner.dat has next line, string line equals scanner dot next line, and I want a set integer droplet set equals new hash set. Great. String line, string coordinates equals line dot split on the regex comma, int x equals integer dot parse int coordinates 0. We're gonna have the same thing for y and z. Okay, I'll do that. Copy, paste, paste. Y, Z, 1, 2, and I'm just gonna say droplet set dot add x times 100 times 100 plus y times 100 plus z. Is an easy enough representation. Let's add some parentheses to make sure that this doesn't go wrong. And then for integer droplet in droplet set, and let's see. So we want to see int surface area equals 0. Int x equals droplet divided by 100 divided by 100. Int y equals droplet percent 10,000 divided by 100, and int z equals droplet percent 100. There we go. And this should be int. It's cool. So now we have all the things recovered. Let's see, we want above, below, left, right, forward, back. So x plus plus, let's just call these the variables x minus minus, y plus plus, y minus minus, z plus plus, z minus minus. If not, droplet set dot contains, and we want, we're basically going to be copying this a bunch. Let's add a little thing right here, x minus 1, copy, and we want now x plus 1, and do the same things. Let's just paste them all and then we can update them. So now x is fine, and now we want crap, okay, plus minus y plus 1 times 100, y minus, oops, nope, y minus 1 times 100. Let's go to this, this, and this. And this is now z plus plus z. We actually don't even have to plus 1 plus z minus 1. And it's just surface area plus plus. So now copy, paste, and now we can just do this each time because it didn't copy the white space. Pertinent surface area plus surface area. Cool. So if we do this and we do level 18 dot part 1, we hit run. Surface area is 0, and that's because there's nothing in the input data. Let's try this and see if we get the answer that we expect. Please run. 64 should be fine. Take this, and now please put that. Run. 3550. Got the right answer. We got 990. This was a really easy problem. Continue to part 2. That took 8 minutes. Something seems off about your calculation. The cooling rate depends upon the exterior surface area, but your calculation also included the surface area of air pockets trapped in the lava droplet. Instead, consider only cube sides that could be reached by the water stream. As the lava droplet tumbles into the pond, the stream will expand to reach as much as possible, completely displacing any air on the outside of the lava droplet, but never expanding diagonally. In the larger example above, exactly 1 cube of air is trapped within the lava droplet at 225, so the exterior surface area of the lava droplet is 58. What is the exterior surface area of your scanned lava droplet? Okay. Interesting. Cool. This problem seems fine. So we want to read in the same stuff. Like this all seems fine. So let's put that here. And ah, crap, my face is still too big. Let's make my face just a little smaller. Yeah, there we go. Look at that. Beautiful. Okay, so now what we want to do is we want to add now rather than surface area plus plus, what I want to do is I want to get like all of the possible surface area things. So let me copy this part, and we're going to change so this, and then instead of surface area plus plus, we're going to have a set integer surface area candidate set equals new hash set. So now I want surface area candidate set dot add this. We're basically going to do that same thing over and over. I want to get all of the places that could be surface area, and then I want to see if I can get from them to like some place outside. I'm trying to think. Okay. Trying to think of what the best way to do this is. Let's start with the implementation we have. So first of all, we need to just tediously copy all of these in there. Seems like I got an extra parentheses somewhere up here. Yeah. Just this. Okay. Easy enough to fix. There we go. So now that we have all the surface area candidates for integer surface area candidate coordinate in surface area candidate set. Yeah, because the surface area you can basically, that's not, oh geez. We don't want to set, we want we basically want to do like a 3D flood fill. Yeah? Yeah, go ahead, get my tag on. Happier? Okay, great. Was it bugging you? Okay, well, wonderful. No longer. Yeah, so we could do like a 3D flood fill kind of thing. But this can't be a set. This has to be like a list. And then add is still fine. And the reason is that we want I'm trying to think like how big is this? It's like 100 by 100 by 100, right? All the values are positive. Yeah, let's actually do this a little differently. Rather than having a set here, what we're gonna do is what's a good representation here? Probably an integer array. Well, we specifically want to be able to set it to null. cube equals new integer 100, 100, 100, 100. Now I want cube x, y, z equals null, something like that. Does that work? And let's initialize this for I equals 0, I is less than 100, plus I, or int j equals 0, j is less than 100, plus j, for int k equals 0, k is less than 100, plus k, cube I, j, k equals 0. There we go, and now we'll have nulls. And then what I basically want to do is I want to like flood fill. So I'm not gonna do this for now. Instead, what I'm gonna do is I'm just gonna like flood fill from the outside is 0, 0, 0. No, it's not. Yeah, and let's read the question again. So, one cube of air is trapped within a lava droplet at this, so the exterior surface area of the lava droplet is 58. So basically I want to use this to construct like the internal solid. So again, I'm trying to think of like how I can flood fill. Let's write a little private static void flood fill integer array grid cube. I called it cube. Call it int x, int y, int z. And that's, let's see whether or not we have stuff at 99 or stuff at 0, because that's going to be the important part. Is music playing? No, of course it's not. Why would music ever be playing? Why would that be a thing that happens? Level 18 data. Okay, oh, sorry about that. Call F99. Yeah. Cool, so if it can touch 99, 99, 99, then we're cool. So now we want cube x, y, z, and it also needs to take in, so if cube x, y, z not equal null, we want cube x, y, z. So if it equals null, return. Otherwise, cube x, y, z equals 1. 1 is going to be the exterior, and we'll have like 0, I guess, be the interior, because it's just not going to add to the surface area. And do we need to? Yeah, so cube x, y, z is 1. And then flood fill cube x plus 1, y, z. And we need to do bound checking on x and y, z. If x is less than 0, or x is greater than 99, or y is less than 0, or y is greater than 99, or z is less than 0, or z is greater than 99. Return. If cube x, y, z is null, or cube x, y, z is 1, because we've already touched this one. Should be fine. Yeah, this is going to be like a little gross, but that's fine. Hopefully not too gross, because otherwise I got to do like more complicated stuff. But I think like this doesn't have to be terribly fast. What matters more is that we like code it relatively quickly. Z minus 1, yeah. So we only touch the adjacent ones, and we're going to start. Now we're going to call flood fill cube 99, 99, 99. I think that that's going to fill everything out starting from the corner, and I think that that'll cover everything. And then what we want to do is we want to, now I think we're going to want to do this, now that we've flood filled it. This, but instead of surface area plus plus, we'll say plus equals, oh, so we still want droplet set. Droplet set dot add. Said it was this. Kept without the plus 1. Great. Then we'll get x, y, and z again. Plus equals cube x, y, z. Instead of this, we can just go yeah, we already have all these conditions. I could write it in with respect to the cube, but I'm not going to. I could actually write the whole thing with respect to the cube, but again, I'm not going to. Cool. Let's change this to part 2. Let's take the original input and try it. Because again, we could try it on everything, but I want to have a sense of whether or not this is working at all. But what is our Stack Overflow error? What? How big can the stack be? Okay, rather than doing it this way, we can do, rather than doing it recursively, you can do this with a queue. Queue, integer, coordinate q equals new q. Oh geez, nope. What are we calling it, a deck? What's an instantiation of q? Q implementations generally do not allow insertions of null methods. Okay, all right, let's look it up. Java Q abstract Q array deck. Yeah, that seems fine. Cool. We want coordinate Q dot add 99 times 100 times 100 plus 99 times 100 plus 99. Cool. while not coordinate q dot is empty, int current element equals, so we can get rid of x and y and z here actually, coordinate q dot poll int x equals current element percent 10,000, not percent, it's divide. Int y equals current element percent 100, or percent 10,000 divided by 100. Int z equals current element percent 100. Great. So now we take all this, we put it inside the coordinate queue, and at the end we're just gonna return. If this, we don't want to return, we just want to continue. If this, we just continue. Otherwise we do this, and then instead of this, we're going to coordinate q dot add x plus 1 times 100 times 100 plus y times 100 plus z. And we can just copy this 6 times. Is that 6? That's 7. Great. This is now going to be -1, so we can get rid of the parentheses. So we can do y plus 1. So we can do y minus 1. We'll fix the x's in a second. Plus z plus 1. Plus z minus 1. 3. The music has stopped playing. Man. My kingdom for audio that wouldn't stop. Cool. So the next one, and it's going to return. Okay, so now we're not going to run out of stuff. The flood fill can't be applied to that. Of course it can't. Cannot invoke Java integer int value because cube xyz is null. Sorry, this should be +1. Should be -1. Because this is telling us if it's on the interior or on the exterior. +1, y -1, z +1. The fact that we already got to this point is actually very encouraging. Looking for 56. We got 58. That's 58's the right answer. Okay. Wow, did we just get an easy problem in here? Run. Oh my gosh. I see. Okay, we're gonna add a little bit of bounds checking here. And x is less than 99. And x is greater than -1. X is greater than 0. And y is less than 99. And y is greater than 0, because otherwise we can't subtract. And z is less than 99. And z greater than 0. Honestly, that check should probably exist in the first part as well. I have a feeling this is probably wrong. actually. Oh yeah, so this is going to be subtly wrong, because if we're up against an edge, that means the outer thing is always going to be there. So let's cut this. If x is less than 99, do this, else surface area plus plus, because then we're on an outer edge. If x is less than 0, do this, else surface area plus plus. If y is less than 99, please do this, else this. If y is greater than 0, if z is less than 99, and if z is greater than 0. Because again, what matters is that there's not magma there. And also, yeah, so now we can delete these checks, because otherwise we wouldn't be adding those to the surface area. That they're at the edge of our grid does not mean that they're not in the surface area. It means that they definitely are part of the surface area. Okay, alright. So 2023, we expect this to be slightly higher. 2280. Okay, so that's actually a fair bit higher. Blah. Cooling rate depends on the external surface area. Include surface instead. Consider only the cube that could be reached by the water. And steam as the lava droplet tumbles into the pond. The steam will expand to reach as much as possible, completely displacing any air on the outside of the lava droplet, but never expanding diagonally. Large droplet above. Exactly 1 air cube is trapped with lava droplet at this. Yeah, because if we comma 0 or 3, if we 99, there's nothing. 0 comma. Comma 0. 0 comma. There are lots. I'm not exactly sure what's going on here. Like, that our answer was so different implies that there are a lot more things. Yeah, if we 0 comma and we only look for the first ones. Because again, if we take our test input, like, nothing changes, right? This is still going to give us 58. Why does this give us 59 now? Crap. Okay, let's go back. Let's put all the things back. Let's hope that it remembers long enough so we don't have to do any of this. And we'll try this other thing, but I feel like this is wrong. Yeah, okay. Alright, let's run this. Now we get 58. Okay, let's put in our real test data and try it again. Run please. 2023. It's not the right answer if you're stuck, blah blah blah. Oh. No, the interior should still be -1. Are we like missing any of our flood fill stuff. Okay, let's look back at how we do this flood fill. We start at 99, 99, 99. Let's write a little thing right here after flood fill to see. Let's write a couple of little helper functions after flood fill. Private static void count lava bits, integer. Let's call it cube again. The music just stopped. I mean, I thought we were going to be done already. And I want a similar thing, but let's start here. Int sum equals 0 for. We can actually copy this from up here. This if cube ijk well, is null, sum plus plus system.out.println number of lava bits from grid plus sum. Cool. Now we're going to do this same thing. Count outside bits. So if this is 1, plus plus blah blah blah. Outside bits from grid. Count outside bits. Count inside bits. 0. Inside bits equals sum. So now I want to call if debug, which we'll come back to. Count lava bits, cube. Count outside bits, cube. Count inside bits, cube. Private, go on. Private static final boolean debug equals true. Run it. Okay, we got a null check first, fine. Not equal known. Let's do the same thing here. Please run again. I just want these to add up to 10,000. Or 100,000. Boolean already printed inside. Dot out dot println inside bit plus I dot integer dot to string I plus integer dot to string j. Nope. we'll actually just represent it like this, so none of this two-string nonsense. Okay, I plus j plus k plus. Yeah, I just want to see these inside bits. Okay, run again. It's too many inside bits. Let's use the. This is the wrong internet thing. Let's use the sample data. They should be so easy. There should be one. Okay, so this seems correct because there's 2, 2, 5, so the surface area is that. And flood filling the outside should work unless there's like a ring of things that are along the outside, but there aren't enough points at 0 or 99 in order for that to work. Because if we look at left, comma 0, there's only 1, 2, 3. And even if we look at 0, comma, it's pretty much all 10s, which is kind of weird, but fine. We should also sanity check this against our answer from part 1. Yeah, here's 1, which we already saw. We only care about ones where it's in the x, but I'm just checking everything because it's easier. Trying to discern if something's in the x value is tough. There's so many 10s here. I think it's so small. Is anything even at like 20? 20. No. 19. Yes. Zero, 1, 1. Yeah, 1 is here, so. I want to make a smaller grid. Now that we know everything's a little smaller, this doesn't have to be 100. I'm going to modify things just a little bit. So Control F. I still want it represented with 100, so I can't quite do it that way. Okay. Yeah, I don't see what the problem is here. Oh, interesting. I came up with like a nice way to make part of this easier. So there's flood fill, and now private static void turn nulls to zeros. Integer cube. Let's hit that music back up. Nice. I'm gonna do the same thing, but instead of sum, because I don't care about the sum, cube I, j, k equals 0. So now instead of checking for nulls or anything, we could just literally get rid of all of these checks actually and just do this. Don't even have to keep the droplet set anymore. Other than to get all the things, which should be easier. So if we do this, do we get the same answer? Oh, well, that's our own fault there. So, what do we call it? Turn nulls to zeros, cube. There we go. Cool. So the other thing we're going to do is we're just going to add 1 to all of these because we know that we're not going to run into any collisions here. This is going to make our edges play a little bit nicer. Why is this inside bit still 225? Probably because we did that for part 1. Wonder if I made any other changes for part 1 that I intended to make for part 2. That all seems fine. Let's go +1. Let's go +1. Let's go +1. Should be 336 now. Yeah. So again, I don't think we've done anything that should change our answer here, but I want to run it again. Our surface area is once again different. 2028. Okay, it's not. I think we were running into an issue where we were like not counting the outside edges, but then when we tried to count the outside edges, then it like wasn't playing nice. Yeah, man, frustrating. Okay, let's go look at the leaderboard. Private leaderboard. Oh no, I just want to look at my stats, personal stats. Oh yeah, much worse for part 2. It took us 38 minutes for part 2, and it took us 8 minutes for part 1. Embarrassing. Let's look at our private leaderboards. Yeah, nobody had even attempted yesterday's puzzle, so I'm all on my own right now. It's not that surprising, and we'll check it. But yeah, nobody's made any progress. I'm alone. It's just you and me out here, folks. Just you and me. Okay, and if we look at the stats for day 18, first 100 users to get both stars, 424 for 5 space, and you solved part 1 in 1 minute. Yeah, if it took you 3 minutes, it took you too long, which and that makes sense. It was pretty easy. It took us 8 minutes, and we weren't really gunning. We even started a little late. Okay, let's do what we always do, and add a new file, level 18 problem statement.md. Do this. Let's just go ahead and get rid of the project view and get rid of this and start cracking down. Go to the top, we're totally fine. Yeah, 1 by 1 by 1 cubes on a 3D grid, and then XYZ needs to be coded. Yeah, etc. This comment does not need to be in there. This, and then we bold it. Here's a larger sample. Oh, and we hit the insert key. That's never good. I know that you want the insert key respected, but I almost never have found a use for that. Oh no, Control B. Yeah, why was I thinking Shift would do what I wanted? Control bold. My answer was 3550. Amazing, 3550, and the second answer was 2028. So the internal surface area was huge. Something's off about your calculation. The larger thing, let's see, 225. It's the only thing that we care about there. Lava droplet is 58. What is the exterior of your lava droplet? Answer was 2028. Both stars are complete. Okay, let's go back through. Let's comment a little bit of this code. Put project back over so it's not all behind my head. That's too big for the project. What if we just went like this? Okay, that's mostly good. We're gonna, nope. We're just gonna go like this. Yeah. Okay, read in all coordinates, insert into set for each coordinate if its neighbor in each direction isn't there, add 1 to total surface area. Easy enough. Part 2. Read in all coordinates offset by 1 so we don't get edge weirdness. Put into set and grid. Flood fill the external volume with the value 1. Turn the rock bits from null to 0 for each droplet, and let's use the term droplet the entire time for each droplet, and the value in the grid to its surface area. This works because other droplets and interior sections will still have value 0, but the exterior was flood filled to have value 1. Let's put a period there. Let's add a thing here. Flood fill the exterior of the given grid with 1s, stopping at any time you find a null, since that implies the cell is already taken. No, or a 1, since you don't want to be flood filling forever. Cool. Pretty easy. All right, let me explain what's going on here. Should probably spell coordinates correctly. So for part 1, we're just trying to compute the surface area of a 3-dimensional shape. So all we do is we get all the coordinates, we represent them as integers, which works because all the coordinates have values. Sorry, let me get the music going. All these have values actually less than 20, but they're definitely less than 100. So this will be a unique representation for every XYZ point. There's no way Z is going to be, for example, 101, which would collide with 0, 1, 1. So we're fine. Now what we do is for the surface area, for every droplet that we see, we compare it to the droplet we see if there are any droplets on every side, which we can just check in our set. And if they're not there, then we add 1 to the surface area. Because if you think about a droplet all by itself, if there's nothing above it, you should add 1 to its surface area because it's got a level surface. Same for each of the sides, same for the front and the back, same for the bottom, which is what we do. So that's easy. That took us like 8 minutes. For part 2, it said, hey, this thing actually is like hollow at certain points, and you only care about what the external surface area is. So think about like this Coke bottle. It's got a bunch of XYZ points on it, but the inside can never be touched by like pouring water from the outside. So I had to come up with a slightly different solution. So what I chose to do is represent the outside, represent everything as like an XYZ cube. And again, this is 100 by 100 by 100, easily fits in RAM, no problem. It doesn't take very long to iterate over. No issues there. So next what we did is we offset everything so we'd know that we had like a full like exterior around it. So we added 1 to all the X's and all the Y's and all the Z's so that nothing is touching the edge of our grid. And that's going to be important for making sure that we can like get a full flood fill around it. So after that, what we do is we flood fill. So we come down to here and we start just from one corner on the exterior, and we know that that's going to make it all the way around because we offset. And then what we do is we check all of the neighbors, and when we read in the coordinates, we made them null, which is why we have uppercase integer and not just int. So anytime you find a null or anytime you find a 1, you terminate. You don't do anything, and otherwise you make yourself a 1, and then you add all of your neighbors to the queue. And so what happens is this queue starts with 1 point, that point comes out, all of its neighbors go in, now the queue has size 6, the one place that we have has value 1, etc. So now what we have is we have a grid where the exterior is all 1s, the droplets themselves of lava are all nulls, and the interior is all 0s, which we initialized earlier. So now if we come back to where flood fill gets called, we had a little bit of debugging stuff. So now what we do is we take the parts that were nulls, where they were droplets, and we convert them to 0s, and that just makes some of our arithmetic later a little bit easier. So now what we do for the surface area is for every droplet, which we still stored in that set because that makes life easy, we just add to the surface area what XYZ is. So if there's another droplet there, then we set that to 0, so we're adding nothing to the surface area, just like we did above. And if it was on the interior, it was 0, it never got changed to null, and it never got changed to 1, so it still is 0. But if it was on the outside, then it got fully flood filled, and that will be a 1. So any external surface area will still see 1 there. And so that's how we end up getting the surface area. So not a super hard algorithm, but one which took a little bit of finagling to get right. In particular, making sure that we offset so we could get a full flood filling around was the important gap for us. We were missing a lot when we didn't do it that way because our flood fill wasn't finding some pocket of stuff apparently. Yeah, so I think that's all I got for you guys tonight. I'm going to go ahead. This took us under an hour, which was a welcome respite. I'm going to log off now, upload the video, and go back to playing a new video game that I've been enjoying. Have a good night, everybody.